Okay, so today we're going to talk about two-dimensional figures, and we're going to begin our discussion with that of a polygon. A polygon is a closed figure formed by a finite or a countable number of sides, with common endpoints and intersections only at their endpoints. Where those sides intersect is what we call a vertex. It's the location of two sides intersecting on our polygon. There are two terms that we can use to describe types of polygons. One is convex. Convex means that there's no vertex inside the polygon, or concave, where at least one vertex is inside the polygon. And you say, well, how do you know whether it's inside or not? Well, if you were to take a pen and you were to connect two vertices, such as these two here, you'll notice that this vertex is now inside that figure. Whereas if we were to do that on this figure, no matter where we drew our lines, we would not be able to have any of our vertices that are inside our figure. So this one here is convex, this one here is concave. Good way to remember that is concave caves in, so this piece right here caved in on my figure. Polygons are named based on the number of sides. Most of you are familiar with triangle, quadrilateral, pentagon. Six-sided figures are called hexagons. Heptagons have 7 sides. Octagon you're likely very familiar with. A 9-sided figure is a nonagon. A decagon, you think of a decade as 10 years. A decagon is 10. A hendecagon is 11. A dodecagon is 12. Anything beyond 12, we use just the number. So for instance, if there's a 16-sided figure, we just call it a 16gon. Those are the easy ones. You do need to memorize these. So let's learn a few more terms to describe polygons. Equilateral, equa meaning equal, lateral meaning to the side. So equilateral, all the sides have the same length. Equiangular means all the angles are the same measure. And then if it's both equilateral and equiangular, we call it a regular figure. So in order for it to be considered regular, it has to be both equilateral and equiangular. So let's try a figure here. I want you to classify this polygon based on the number of sides. I want you to tell me whether it's concave or convex, and whether it's regular or irregular. If we begin by counting the sides, there are 1, 2, 3, 4 sides, which makes this particular figure a quadrilateral. If we connect vertices, we will at no point have the figure that caves in. Therefore, it is considered convex. None of the sides are equal, so that means that it is an irregular figure. Okay, now for this figure, I want you to name it based on the number of sides, state whether it's concave or convex, and whether it's regular or irregular. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, which makes this figure a nonagon. If we were to connect, let's just say this vertex down here with this vertex over here, I do get several points that are inside now, which means that my figure is going to be concave. And there are several different lengths of sides, so that means it has to be irregular. I will also note that if it is a concave figure, it has to be irregular. Okay, let's classify this figure now. There are 5 sides, which makes this a pentagon. It does cave in, point C, therefore it's concave. And since it's concave, it has to be irregular as well. For this figure here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, which means it's a nonagon. It does not cave in, so it is convex. And if you'll notice the markings, all the sides have the same length and all the angles are the same measure. Therefore, we would consider this regular. Most of you know a stop sign is in the shape of an octagon. It is convex, it does not cave in anywhere, and all the sides and angles are equal. Now we don't know that for certain based on this figure, but it is designed that way, so we would consider this regular. This is a four-sided figure, therefore we would consider it a quadrilateral. It is convex, and it is also regular. This figure here trips up a lot of people. A lot of people say it is a triangle. However, if you count the number of sides, we have 1, 2, 3, 4, 5, 6 sides. Therefore, this figure is a hexagon. It does not cave in either, so it is convex, but it is irregular because not all the sides and not all the angles are congruent. With polygons, you also have the distance around the object, which is called perimeter. Peri meaning around, and meter to measure. In general, in order to find the perimeter, you just add all the sides together. There are a few objects that have formulas that you are welcome to memorize, one of which is the parallelogram, 2L plus 2W. If we're talking about the perimeter of a circular object, such as a circle itself or a cylinder, we use the term circumference. Circumference is equal to 2 pi r or pi d. These formulas you will also need to know. So the perimeter is the distance around an object. The amount of surface an object covers is known as the area. And many of these formulas you likely already know. For instance, the area formula for a parallelogram is base times height. That is true for things like rectangles as well. The area of a triangle is 1/2 the base times the height. If I use a parallelogram as an example, if we were to cut this parallelogram by diagonals, we would have two triangles that are equal in size, each one being half the parallelogram. So that is how we get the area formula for a triangle is 1/2 the base times the height. And then the area of a circle is pi r squared. So based on that, let's see how you do with finding the perimeter and area of this figure. I'll give you a few moments to start. So if we look at the perimeter, this is a parallelogram, so it's 2L plus 2W. My length is 2.3, my width is 4.6. When we add those together, I end up getting a total of 13.8. Now to find the area. To find the area, we take the base of 4.6 and we multiply by the height of 2.3, and that gives me a final area of 10.58 square centimeters. If we move on to the circumference and area of this circle, here I am given the radius, so I'm going to use the circumference formula of 2 pi r. So I take 2 times my pi value times my r value, and that gives me approximately 25.13 inches. You can either use 3.14 on your calculator or the pi key. To find the area, we take pi r squared. In the course of area, you do need to use the radius. You cannot use the diameter. So here I have 3.14 times 4 squared. 4 squared is 16, giving me a total area of 50.27 square inches. So the perimeter of this figure, since it is a square, we can simply take one side, which is 11, and multiply by 4, giving us a total perimeter of 44 feet. If we use the parallelogram formula, we would have 2 times 11 plus 2 times 11, which of course is still 44 feet. To find the area, we just take the length times the width. 11 squared is 121 square feet. In this particular case, if I'm looking for the circumference, I am given the diameter, so I can use pi d. So if I take this diameter of 12.8 multiplied by pi, that gives me 40.21. Now when looking for the area, I cannot use the diameter. I have to have the radius. So my first step is going to be to figure out what is my radius. My radius is going to be half the diameter. The diameter is 12.8, therefore my radius is 6.4. Now that I have the radius, I can use my formula. Pi times the 6.4 squared. When I work that out, I get 128.68 square centimeters. To find the perimeter of this figure, I simply need to add all the sides together. 15 plus 8 plus 17 gives me a total of 40 meters. Now, to find the area, I do need to use the base and the height. This is a very important aspect. The base and the height are going to be at right angles to each other. So if you'll notice the right angle symbol, perpendicular symbol there, that means that the 15 meters is my base and the 8 meters is my height. I am not going to use the 17 because that is not a base or a height. So I take 15 times 8 and that gives me 60 square meters. It's very important that you use the base and the height, and they are going to be at right angles to each other. Alright, now for something a little bit more of a challenge, something that you likely haven't done in the past. When points are given on a coordinate plane, you may have to use the distance formula that we learned earlier to find the side lengths. So let me give you this example. Let's say I wanted to find the perimeter of this figure. Well, some of the sides I can see very easily and I can measure very easily. For instance, going from E to D, I have a length of 5. Going from C to D, I have a length of 6. However, BC, AB, and AE are at an angle. So I cannot just count the number of squares, I have to figure out the actual distance of those particular sides. So if I begin by finding out what AB is, if you notice that point A is located at 0, 4, point B is located at 4, 0. So I find my change in my x's, 0 minus 4, and square it. Find the change in my y's, 4 minus 0, and square that. I end up getting 16 plus 16, or 32. So that length is the square root of 32, or 5.7. I'm going to do the same thing with side BC. With point B, I have 4, 0. With point C, it's located at 3, negative 4. So my change in the x's is 4 minus 3. My change in my y's is 0 minus a negative 4. That gives me 1 squared plus 4 squared. 1 squared is 1, 4 squared is 16, so 1 plus 16 is 17, so the length of that side is the square root of 17. So we continue that process on. I do know that CD is 6, DE is 5, and now I have to figure out what AE is. A, again, is at 0, 4, and E is at negative 3, 1. So when I find the distance there, I get the square root of 18, and now I can add all those pieces together to give me my final perimeter of 25. So if you do not know the distance formula at this point, you need to learn it. Now let's try the same figure. This time we're going to find the area. Area can be a little bit more of a challenge, but we need to break it up into pieces that we know. So as an example here, I can break it up into two triangles, the pink triangle and the green triangle, and then a rectangle that is in blue. Well, that pink triangle, I know the formula is 1/2 the base. My base is 6. My base is going from point E directly over to this point here. That's a length of 6. And my height, again, needs to be perpendicular. So it's going from point A straight down perpendicular to my base. And that has a height of 3. So the area of that portion is 9. I do the similar thing with my green triangle. I have a base. If I start at this point here and I go straight down to C, it gives me a length of 5. Perpendicular to that, the top point is 1. So my area there is 2.5. And then of course the rectangular piece, which is length times width, or 5 times 6, gives me 30. I add those values together to give me the total area of 41.5. Let's try this one. We need to find the perimeter of the area when we're given coordinates. So point A is at -1, 2. So I'll plot that point. Point B is at 3, 6. And point C is at 3, -2. So I have this figure. So now to determine the perimeter. Side BC is going to be fairly easy. We started up here at 6, and we went down to -2. So there, this side here is 8. However, I do need to find the length of AB. The length of AB is equal to the square root of my change in my x's. I went from a -1 down to a 3, up to a 3. And then add my change in y's. I went from 2 to 6. So that gives me the square root of -4 squared plus the square root of 4 squared. So that gives me the square root of 32. And now I need to figure out AC. Again, we find the difference in my x values going from A to C. I have -1 minus 3 squared. And then I'm adding the change in my y's at -2, 2 to a -2. So that gives me a -4 squared plus 4 squared again. So I end up getting the same answer, that of the square root of 32. So my final answer for the perimeter is going to be 8 plus 2 square root of 32. Now the square root of 32 does simplify. If we prime factor, we get 2 and 16, which is 2 and 8, which is 2 and 4, which is 2 and 2. So we bring out a group of 2's here, another group of 2's. So that gives me 8 plus 8 square root of 2. Now, what about the area? Well, the area is actually fairly easy in this particular case, because we already have, if I use this 8 as my base, and I go straight from A down, making a perpendicular, I get a length of 4. So my area is then equal to 1/2 my base of 8 times my height of 4, which gives me 16 square units.